Good morning, everybody. In today's lesson, we're going to continue with our sequences and series with two or more sets of information. In our first example, they say that the first term of a geometrical series is 4. So the first term is 4 and we have a geometrical series. The last term is 1 over 1 to 8 and the sum is that fraction. So they give us a lot of information. We know it's a geometrical sequence or a geometrical series. Therefore, our general term will be a times r to the power of n minus 1. And our sum formula will be a times r to the power of n minus 1 over r minus 1. We are going to use those two formulas because of a geometrical series, and they tell us the first term is 4. So T1 equals 4. The last term is 1 over 1 to 8. So T of last equals 1 over 1 to 8. They also tell us that the sum is that. So Sn equals that value. The first term is always a, so they give us a. A is 4. Now let's work with this formula of term last equals 1 over 1 to 8. The last term is also Tn. So Tn is 1 over 1 to 8, and that equals a, which is 4, times r to the power of n minus 1. I want to get rid of this 4 because I need to get the common ratio. So I want r alone. I'm going to divide by 4, and then I get 1 over 512 equals r to the power of n minus 1. Now I'm going to rewrite this as r to the power of n over r to the power of 1. And I'm going to leave it just a little while. Our next clue is the sum clue. So I'm going to use this formula and substitute everything in that I have. So the sum of Sn equals 1023 over 128. Therefore, 1023 over 128 will be equal to a is 4, r to the power of n minus 1 over r minus 1. And this is my second equation. Now I see that I have an r to the power of n in this equation. And I see I have an r to the power of n in that equation. So let's get r to the power of n alone in this equation so that I can substitute this value into equation number 2. So I'm going to multiply here with r to get rid of this r. If I multiply with r, I have r to the power of n, and I multiply r here, then I have r over 512. So this is my equation 1. I have r to the power of n alone, so I'm going to substitute that into 2. So let's do number 1 into 2. 1023 over 128 will be equal to r over 512 minus 1 over r minus 1. Now I'm going to cross multiply to get rid of the fraction. So 128 times r over 512 minus 1 equals 1023 times r minus 1. Oh, sorry, there's 4. This all multiplies to 512 times r over 512 minus 1. And here I have 123r minus 1023. If I multiply this, I will get r minus 512 equals 1023r minus 1023. Get all the r's on one side, then 1022r will be equal to 511. Now I want r alone, so I'm going to divide with 1022, and then r will be equal to a half. And that's our first question. Calculate the common ratio. So r is half. The follow-up question, they want the number of terms. So I'm going to use this clue again of the last term equals 1 over 128. The last term is also term n, and that equals to 4 times r to the power of n minus 1. I know what the term n's value is. It's 1 over 128 equals 4 times, I know r has a value of a half, we just calculated that, to the power of n minus 1. Remember, when you have a fraction and you need to give it an exponent, always put it in a bracket. You can't now divide the 4 and the 2 into each other because the 2 has an unknown exponent. So I'm going to divide this whole right hand side with 4, and I have to divide this side with 4 as well, and then I get 1 over 512 equals a half to the power of n minus 1. This 512 is 2 to the power of 9. So I'm going to take it to the numerator, then it becomes 2 to the power of minus 9 equals. This 2 becomes 2 to the power of minus 1 to the power of n minus 1. Now I have to multiply this in, so it's minus n plus 1. If the bases are the same, the exponents are the same. Minus 9 equals minus n plus 1, and if you have n alone, n will be 10. So this series has 10 terms.